let's get started here today. Sorry about not having class on Wednesday. Flights got delayed and everything got messed up, but that's how it goes. So here we are today. Before we get started talking about these things on our list, if you haven't noticed yet, there is Lab 2 posted on D2L. So that is due Sunday at midnight. I did post that a while ago. One of the things I usually like to say with my classes that I did forget to say with this one is that if you haven't yet, which I hope you have by this point, but hopefully you've turned on D2L notifications right now. So most of the time when I'm canceling class and I'm doing other things like that, I'll just post it here on news instead of posting it on news and redundantly posting it to email. Now I don't know what the defaults look like anymore, but at least when I first started at DSU, these notifications, so if you go back to the main page and hit notifications, I like to check, at the very least, news, new item available, and then grades, grade item released. And then you can select how you actually want to receive those notifications. I just have them by email. You could actually have SMS notifications as well, which is kind of neat, I guess. But I certainly, at the very, very minimum, recommend getting notifications on news item available if you haven't done so. And yeah, that's about it. So just really quick, I guess I can talk about Lab 2 as well. It's pretty simple. It's wrong class. Pretty simple. Based on that pseudo stuff we talked about adding users to groups and stuff. So I just want you to create a new user, Lab 2, set their password, and then give sudo permissions to that user. And then a couple screenshots and perhaps a little explanation of how you actually did that and went about doing that. So if there's any questions, of course, feel free to email me whenever. So that. Okay, so today, talking about basic using services, basic network commands, and then SSH D. So we're going to talk about the client SSH portion, and we're going to talk about the server SSH portion and how we would configure both of those. And surprisingly enough, we can actually configure a lot in the client that you might not have expected to start with. Some of it's kind of a little bit foggy for me, so I'll have to look at my configuration that I have for my... So we're going to start looking at that. Okay. So I got two Ubuntu boxes here, so we're going to be looking at SSHing between both of them, configuring SSH to SSH between both of them. Now I've switched to a white terminal, so hopefully that will alleviate some of our problems, but if something's not visible, let me know. The blues might still be bad, so I might eventually switch to just all black and white, but we'll see how it goes for now. So as configured by default, at least Ubuntu server, at least when I configured it, I think I manually selected SSH server to install it when I was going through the installer to do it. So I believe, if I remember correctly, you would just sudo apt-get install open SSH server. Yep. So if you did not have open SSH server installed, that would install it. I believe it would automatically start it up. If it didn't, we can use two different commands. We can use the newer systemctl command, and then the start verb, and then I believe it's SSH. Okay, that also requires sudo, so I need to run that as sudo, and it would start SSH. On a number of different platforms, this SSH might be SSH, might be SSHD, might be Open SSH Server, might be a number of things. So kind of have to mess around sometimes to figure out exactly what it is. The other way of doing it was with service. So this is the traditional way of doing it on a number of other distributions and kind of older systems is sudo service. And then this time we say the service name first, and then we say start. And that would also start the service. So, let's see here. To see actually that service is running, we can have this little command that's kind of fun. We could, well, I guess from a service standpoint, we could say systemctl status SSH. And the one part that we're looking for right here is this active part. So we'll say active running, and that actually will give us a nice little log of some of the different things that are going on with that service. So let's just really quick stop it, systemctl stop, and then SSH, and then say status SSH. You can see it will say inactive dead instead of active running. So you can see that that's how that works. So we'll start it back up. Another important thing to remember with systemctl, I'm sorry, it's kind of just things that I could get more in, we're going to get more in depth into like how services work and everything, but just for right now we want to just show how we can do stuff with SSH. So the two other commands, so we saw start, we saw stop. To start and stop services, we have enable and we have disable. So when we say those things, what that does is it controls what happens when the system starts. So we say enable, it means that the service will be started when the system starts. When we say disable, it means the service will not be started when the system starts. So we want to keep that enabled right now. By default, it should be enabled, I believe, but just something to keep in mind. So that's kind of just the basic service stuff I wanted to cover right now so we can get started. Both of these boxes already have SSH installed. I'm going to reset my password here because I changed it before, so I'm just going to reset that back, hopefully. Nope. Okay, 1 second. Bear with me here. All right. So let's look at what we're going to do. Basic network commands. So hopefully you all remember ifconfig, kind of the basic way to get your IP address, very much like ipconfig on Windows. We can see we have the interface name and then this block of information about it right here. So we have our Ethernet device and we have our loopback local device. So one important thing to remember about device names, well, it's not really important. It doesn't really matter at all, actually. On older Unix systems, on older Linux systems, like Ethernet also always used to be called ETH0, and we're kind of getting away from that. Most have these dynamic names now. So let's look at this here quick. Okay, it's just the same. So there will be kind of ENS and then a randomly generated number, and that's controlled by the distribution. So you might see different things in different distributions, but just you can kind of look at that, look at the IP address. Yep. So it was all based on the way that you were actually figuring out what ETH0 was. So they decided that a MAC, so basically the way it used to work is it was just whatever was detected first. So if you're provisioning like a box that has a bunch of different network cards, it wasn't guaranteed that you would always get the first NIC that was labeled 1 as ETH0 and things like that. And I don't know exactly why things are the way that they are right now. I think it looks more in the BIOS to figure out what's going on. But that is a solution for a problem that I didn't realize existed. So that's just kind of why, I guess. So to basic get your IP address command, it was ifconfig, and that was the traditional way of doing things. So now, in fact, you'll get on a lot of Linux boxes, not this one particularly, but they won't have the ifconfig command anymore. Now we have the IP command. So the IP command puts a number of different commands that you might be familiar with under one single command. So we had ifconfig before to look at IP addresses and assign IP addresses. We had route to look at routes and things like that. I believe it has some ARP capabilities too, but I don't know much about those offhand. So just at a very basic standpoint, we could say IP ADDR to show our IP address. So again, a little bit different, perhaps a little bit more parsable, machine readable. We have our name here, and we have our IP address right here. So I think I'll get more into actually using IP addresses and stuff later. But for right now, let's SSH from this box over here on the left to this box over here on the right. So let's grab this IP address. We see this is 253.55. This is 54. It would probably look very similar on your VMs. So I would just say SSH DSU at that IP address. So let's talk about this a little bit. So every time you SSH, regardless of what client you're SSHing from, it should ask you to verify the authenticity of that host. So every time you connect to this box, there's this handshake. We'll just kind of leave it kind of simple right now. And based on the results of that handshake, you know the key of that box. So I know that was kind of terrible. I'll admit, that was a terrible description. So there's this folder, SSH. So there's these host keys. So SSH host, ESD, SA, RSA key. And there's all of these different keys that identify that box. And when, by default, so this isn't necessarily the way it is, hopefully it's this way, when you start up the box for the first time, when you install it for the first time, these are randomly generated keys that will only be able to be used for this box and shouldn't be duplicated. Now, as it turns out, I actually cloned these VMs. So my VM on the left was a clone of my VM on the right. So these keys are actually the same. So we might get into more depth with SSH keys later, but that's something you don't necessarily want to have happen. You want your keys to be regenerated for every box, so you can identify that box as being unique. Now, the whole point of these keys is to prevent man-in-the-middle attacks. So if you have trusted this box before, this 253.55, you connect to it, you accept the authenticity of the key, and then you try and connect to it again, and it prompts you again. There's either something wrong with your system, or there's somebody trying to man-in-the-middle you and steal your credentials. So the one other thing to note is if there's somebody on the network from the very beginning, and you accept their key to start with, you can actually still figure out that that's happening. And I don't know exactly how to do that at this time, but it does have to deal with looking at these public keys. Host RSA key.pub. You could actually take, I think it's the hash of this file, if I remember correctly, and compare it to this string right here. If you had physical access to both of these boxes and actually compare those keys. Sorry, I didn't have anything prepared for that. I'm just going off on little tangents right now, but maybe I'll look at that a little bit later. So again, if anybody's from the very beginning, is man-in-the-middling the connection from the very beginning, and you accept their key, you wouldn't really be able to notice unless you actually check the keys yourself. So right now, I'll just accept it, and it failed. So when you're connecting via SSH and you don't connect after a certain period of time, it will actually just kill your connection. So now we can see I connected again the second time after that key's been trusted, and we don't get that prompt again. And again, we do it again, and it's still perfectly fine. So you see, my host name here is now Ubuntu 2 because I SSH'd over to that machine. Okay, so that was the very basic way of SSHing. So I say my username here, and then I do that, and then I say my password, and it sends my password over to Ubuntu 2. And so on and so forth. So another kind of interesting thing that we can look at is our PS output. So I honestly have no idea what aux stands for. Basically, it gives you all of your processes, but the important one that I like to do too is F, which gives you a tree. Of course, I can't actually see any of these things right now, so I'll just kind of make this a little bit bigger. So now remember we were logged in over here. We can actually see that we're logged in over here by looking at the SSH process, and then we can see the child processes off of the SSH process. So we can see I'm actually SSH'd into, I'm SSH'd all over the place, unfortunately. It's going to make things difficult to explain. But basically, the SSH session over here on the left is this one right here. So one interesting thing that we can do is, let's say we wanted to kill that SSH session. So we can actually take this. Since that process is owned by root, Now we'll just take this PID here, we'll say sudo kill, and we'll give it that number, and then just watch this over here. We can see that we just killed that SSH connection by killing the processes associated with it, so that's kind of interesting. Tangential, but interesting. So let's log in again. So let's talk about how that's actually configured, and let's look at how the system knows whether to allow a user on to that system or not. So we're in this etc SSH directory that contains both our client configuration, so that's SSH_config, and we have our server configuration, SSHD config. So let's look at SSHD config, since that configures our server. So basic stuff like what port is SSH going to listen on. Okay, let's go back really quick. So one other thing that we can look at is netstat. So netstat shows us our current network connections. So we could say L for listen, T for TCP, N for don't resolve DNS names, and then P for who owns that particular port. So we can see we actually do have SSH listening. So we have listening on all hosts, all interfaces, sorry. And we have port 22, so if I run that as root, it actually tells me that that is run as SSH, and SSH is the process responsible for binding to that port. And that's kind of interesting stuff to know. So going back, sorry I got off on that tangent again, love doing that. We can configure what port SSH is actually listening on. So let's do this really quick. Let's just change what port SSH is listening on. Sudo. Let's change it to 2222 instead of 22. So I've changed my configuration, but if I, of course, look at netstat, we can see it's still listening on 22. So every time we want to update our configuration file, we have to restart that service. So we say systemctl restart SSH. I didn't sudo it again, so restarted SSH. Look at netstat again. Now we can see it's listening on 2222. Go back over to, but okay, another random interesting thing that is just interesting, doesn't really provide any value, is even though I changed the port on that SSH server, like all my clients are still connected. You can see over here that I'm still on Ubuntu over here, and then I'm still on Ubuntu over here, even though I changed the port, which is just kind of an interesting thing to know. But if I disconnect and I try and SSH again, it will just say connection refused. There's nothing listening on port 22. So to change that, we say P and then our port number. I think it's lowercase p, we'll see. And now we're allowed to connect again. Sweet. SSHD config again. I'll just change it back to 22 just so I don't forget about it. And all that. So another interesting thing, I might demonstrate this later, is if you have multiple IP addresses on your box. Let's say you have a virtual server somewhere and it has multiple IP addresses, and you have like a web server running on, you might want a web server running on one, you might want a SSH server running on the other. You could actually specify which exact address to listen on, and you would just specify that right there. Some stuff here. Configuring all of those keys that we saw earlier. So here's another interesting one, the permit root login. So by default, I believe there's 3 ways that this can be in. You can say yes, you can say prohibit password, and you can say no. There might be some more. I'm not exactly sure, but those are the 3 main ones that you want. So let's talk about that. So by default, most of the time, SSH won't allow you to log in as root with a password. So preventing root entirely, you would say yes. That wouldn't allow you to log in as root at all over the network. Prohibit password, it would only allow you to log in with keys. So we're going to talk about SSH keys in a little bit here. But just remember that in order to log in as root, we would have to have a key that was authorized. Remember that word, authorized, to log in as root. So right here, these 2 allow us to actually use key authorization. permit empty passwords, things like that, just blocking things that you'd normally if you were SUing to another user and you were prompted to use their password or enter their password, it would allow you to enter empty passwords. So these are kind of interesting things too. X11 forwarding. If you are running, if let's say this Ubuntu 2 box over here is a GUI box, you could actually run GUI programs on this box, but render the program on your own box. So, well, we'll talk about that later. It's kind of complex stuff. The other one that I was looking for was TCP forwarding. And the other thing you can do with SSH is, I think it's configured by default for you to allow, which allows you to do it, is actually forward TCP connections and network traffic through this box. I'll just demonstrate how you might go about doing that quick. I have to go back and I have to restart SSH really quick here. You could actually say D and then 8888, and that would establish a SOCKS 5 proxy through that box. Now you could go into your system, you could go into your browser, and you can configure that proxy. You can configure your system or browser to route all their traffic through that proxy, and then all of your network traffic would effectively be routed through the other box without really any configuration. And what's really nice about that is, again, there's no configuration. If you're doing a full VPN type of thing, it would be very, very complex. But with any system that has SSH, should generally allow that to happen. We can configure that not to happen, so in a lot of environments you might not want TCP forwarding to be enabled. But we'll talk about that later. I don't think we're going to have enough time to cover everything I wanted to today already. So let's talk about keys. So let's try this. Let's try one more thing. Let's try actually logging in with root and see what happens. So I don't know if I actually ever set the root's password, so I'm just going to go do that really quick. Alright. So let's, instead of trying to SSH into DSU, let's try and SSH into root. Okay. So I typed the right password, but it still said permission denied. So that was just basically not allowing root to log in. So let's talk about SSH keys. This is good stuff. So in your home directory, remember we got our home directory right here, and we can say lsla to list all the permissions and such, and list hidden files. So L is hidden, or A is hidden files. So we have this cool little folder called SSH in our home directory. And for most users that use SSH, they will have this SSH file directory. Sorry. So right now we only have one file, and that's known hosts. So when we SSH to another computer and we accept their keys, we say, yes, we trust this device. That key is actually stored in here. Now, one thing that is kind of tricky about this is they're actually hashing something that's kind of new that caught me off guard a couple months ago, was they're actually starting to hash the IP addresses that go into these files. So instead of being able to look at this file saying who has this box connected before, looking at an IP address, and you can see that down the left side on an old box, now that IP address is in fact hashed. So you don't really know where that box has been SSHing to. But that was a very common thing to do. Let's say when you hacked a Linux box, you go straight to this SSH folder and copy everything out of it right away. And if there were keys installed, if this thing that we're going to do next, there were keys installed in other boxes, you could just figure out where that person had SSH to before, and then do the same thing with their keys that were stored here. But, again, tangential, sorry about that. So, let's look at this command, SSH keygen. So what this will do, by default, will generate this key pair file, and it will store those keys in this .ssh directory in IDRSA. So this is right here is our private key. We'll talk about passwords in a little bit, and then it will save .pub as our public key. So we can actually change where we want this. Say we could have multiple key files. in different places. When we were SSHing, we say SSH-I to manually specify which key file we want. Sorry. So let's say I had key. I just had this random key that was floating around that I wanted to use. What I could do is I could say SSH-I and then this key file, and it would use that key file to connect. But by default, it would look in SSH here, and it would use this ID RSA by default in the home directory, in the SSH directory, and then again find that ID RSA. So when we try and connect to DSU again, or this other Ubuntu 2, when we try and connect to Ubuntu 2, we're still prompted for our password, which is expected. So in order to deploy our keys from our Ubuntu box on the left to our Ubuntu box on the right, we can actually use this command, SSH copy ID. Then we'll say DSU at 192.168.253.55 again. And what that will do is it will try and log in with the keys to start with. If it cannot log in with the keys to start, it will log in with the password. It will try and log in with the password. You'll be prompted for the password. And then it will automatically install those keys on the right here. So something important to remember is we had the exact same SSH setup to begin with. All we had was known hosts over here on the right in that SSH folder. But now when we look at it, we also have this authorized keys file now. So when we generate our keys over here and we SSH copy ID them over here, what that's doing is if the authorized key file does not exist, it creates it. And then it will take that key that we just generated, this, we'll just cat that out really quick here, SSH ID RSA.pub. It will take that pub key file and it will place it over on this server. And as we can see now, if we SSH in there, we are allowed to log in without any password or anything. It just allows us to log in right away, which is pretty cool. Which is super nice if you're a system administrator, you're logging into a bunch of different systems all day long. You don't want to be retyping passwords. You don't want to be even managing passwords necessarily. And especially if you're doing kind of automation things, automatically configuring things, retrieving files, copying files automatically, you certainly don't want to be using passwords because you'd have to sit there as a system administrator and manually type in the password every single time, which of course is no fun. So that key that we just copied there, it only applies to this one particular user, this DSU user over here. Just really briefly, if we don't know this already, sorry, I'm SSH'd in. I should have changed my terminal theme or something like that to make it more apparent where I was at, but of course didn't do that. So when we're doing this, just remember that this is our private key, this is our public key. So when it comes to private and public keys, pretty much in general, everybody can know this public key, so it doesn't matter who knows this. It's this private key that you need to keep safe, that you need to keep protected and secure. So I can put this public key on any number of servers, on any number of different servers that I want to log into, put it in their authorized key file, and I can SSH into them, but they cannot SSH back into me. So it's kind of an important distinction there. If I were to take and generate keys over here and put them over here, then that would work. And I would be able to log into Ubuntu from Ubuntu 2. Sorry for the names again. Okay. So let's also do this really quick. Let's look at what happens when we don't have SSH copy ID. So there's a number of systems which we might get onto which we don't have SSH copy ID, and we're kind of confused about what to do. So let's do this all from scratch. Let's remove authorized keys, and let's demonstrate that that does not allow us to log in anymore. Okay, so normally when I would have done this, it would have not prompted me for a password, and it would have logged me in immediately. So I had to type my password again. So we can use the SCP command, secure copy, which copies files over SSH to actually copy are, actually I logged out and I logged back into my host. So we can use SCP to actually copy that file from here to there. So I would say scp .sh. I'd say my source, just like regular CP, there's a source file and there's the destination file. So I'd say scp id rsa.pub, and then I'd say dsu at 192.168.253.55, and then I'd say where I want that file to be located. So if you just want it to be in the home directory, you could say colon and then dot, and that would drop it right in the home directory. Still have to type in my password again, and we can see there was successful transfer there. If, for instance, I left off that colon dot or something, it would just die and it wouldn't do anything, because it expects a path here and it doesn't give you an error for no apparent reason. It should give you an error, but it should. Well, it doesn't. So let's say I wanted to put it in another directory. Let's say I just wanted to drop it in temp. I could say temp. Still be prompted for my password again. But if I go over here, go over to temp, we can see we've got that ID RSA pub right there. We got that ID RSA pub right here. So from this first box, I'd want to SSH into the second box. Considering if this was fully remote, that I didn't have console access to this one, I'd want to my keyboard shortcuts are messed up here a little bit. Okay, log into that, and I'd want to cat id rsa.pub, and then redirect that into SSH, authorized keys. So, important thing to remember with this, super important, I should scroll this up since it's so important, is that when you're doing this, and you have multiple people that want to log into this system, never, ever use the single bracket alligator thingy. So if you use the single one, that will overwrite the entire file. Remember, if you use two, that will append it onto the end of the file. And if it hasn't been created yet, it will create it. So remember, single overwrites the entire file, double will append it to the file. So now we have this authorized key file, and hopefully if I did everything correctly, now when I go to log in, voila, we're just given our instant access. So that's what's happening behind the scenes. It's copying that file over. Sorry, what SSH copy ID is doing behind the scenes, it's copying that file over, and it's appending it onto authorized keys. But there are certain distributions, certain environments in which you might not actually have the SSH copy ID command. For instance, macOS by default, I don't believe has SSH copy ID. Just a random thing. So that's kind of SSH keys. So let's look at how we would do that with another user. Let's say we have access to one user, but we don't have access to another user. In this case, root. We can't SSH directly into root with our password, but maybe we want to gain root access. So I have to switch to root in order to be able to modify their SSH directory. So each SSH directory is owned by that particular user, and perhaps when I try and do this, there's no SSH directory by default, so I have to make it, mkdirr.ssh, and cd again. I could do the exact same thing and say, I remember how I dropped that ID RSA pub in temp, so I could just say temp ID RSA.pub, change my path here a little bit, since I'm already in that SSH directory, and now we have this new authorized key file, right there in our root directory, pwd. So let's go back over here. Let's try and log in as root. And again, if everything went according to plan, we should be allowed to log in directly as root without any password. Oh man, that's magical. Okay, so remember, the whole entire reason we were able to do that was this line in our SSH configuration. So we have this, where is it at? Permit root login, prohibit password. So it won't allow you to use a password, but it will allow you to use a key file, which is, if I haven't said it yet, is also actually way more secure than a password. And I could get into why, but it's not particularly relevant. So let's just change this really quick to say permit root login and say no. Again, we'll have to restart it. System ctl restart SSH. And then we try and log in as root again. Remember how that just succeeded before. We try it again. It doesn't work to start out with. Still prompts us for a password. Try my password, and we get nothing. So we're completely locked out of the root user. We cannot log into them at all. So another interesting thing that's worth looking at is the users and groups behind all of this. So what users are actually allowed to SSH in? So we have a couple directives that we can use to control that. Let's actually make a new user really quick to demonstrate this. User, so we'll say user, you'd still be root, that was a mistake. So, user add, make their home directory shell bin bash, we'll say SSH test, set their password, and then we'll go back over here, and instead of logging in as DSU, I'd log in as SSH test. And by default, we're allowed in. So what that demonstrates to us, at least on Ubuntu, this isn't the case on all systems, when we create a new user, and at least they're given a shell, they're allowed to log in SSH by default. And that's, in my mind, certainly not the behavior that we want by default. It's interesting behavior, it's not necessarily what we want though. So we should configure that. We could go over to SSH here. Remember how we talked a little bit about using groups to control different things? There are a number of directives that we can use in our SSH configuration to instruct SSH as to what groups are allowed to log in. So just like, I don't want to give the lab assignment, but just kidding. I thought we'd already finished that. Okay. So I think by default, we have an actual SSH group. Yeah, see, we actually do have an SSH group that's created by default when we install OpenSSH server, but it's not actually configured at all. So let's do this. Let's configure our SSH server to only allow a particular group to log in. Kind of interesting behavior. So just for sanity, I'm going to make all of our new options down here, and I believe, if I recall this correctly, it's groups allowed. I'll go to the man pages really quick, search through it really quick, and figure out which that is. Allowed groups. Allow groups is the directive right here. So we could just say allow groups, and then we could say SSH. I think it's comma separated too, so we could say a number of different groups. But for right now, we'll just say allow only people in the SSH group to SSH into that machine. So we'll restart SSH. And oh no, what happened here? Now we're locked out. So let's pretend that we just restarted SSH as a remote user, and now we're locked out of that box. Congratulations. So let's pretend, in that case, you have to go over, you have to obtain console access to actually change anything. So we're just going to pretend that we have console. Well, we do have console access. So we're going to add our SSH test user. Let's just add DSU for now, I guess, since I'll continue to use that throughout the semester. So we'll add to the SSH group DSU. So now, when we try and SSH in as DSU, again, we should have that key file installed. If everything goes according to plan, this should instantly be granted shell access. And there we go. But now, of course, the default behavior is only users that are specifically allowed, that are specifically in that SSH group, are actually allowed to SSH to that server. So that's perhaps something you want to configure when you're administering a system. You'll probably have a number of different users that are created for a number of different reasons. And you might not want just arbitrary people SSHing into arbitrary users. Yeah, so that's kind of powerful. Unfortunately, I logged out twice again here. So, let's see, what else do we have here? Running out of time real fast. So, let's just look at that SSH directory thing, or SSH config thing again, group. So allow group. So there's a couple interesting things. You can deny users, allow users, deny groups, and allow groups. So I won't get into this, but deny users and allow users take usernames, and deny groups and allow groups take group names. So I could specifically have blacklist or basically a whitelist, and that's the way that those go. Here's the other interesting thing that the directive that I was looking for before was allow TCP forwarding. So if you don't want people to tunnel TCP traffic through your server, you would configure that to say allow TCP forwarding no, and that would prevent people from doing that. But I think by default it's enabled. Couldn't say for sure. But okay, finally, last thing I want to talk about was the client SSH configuration. Let me check and see how mine worked here quick. Do I not have a config here? Shoot. So, on the client, we can actually have an SSH configuration too. And what this is useful for is creating shorter names, kind of remembering ports and things like that that we might not want to by default. So we can go into SSH here. We can say vim config, I believe it's called, and then we would say host, what are we at here? We would put in the IP address or the host name, 168.253.55. We could say user DSU, and if I remember what I'm doing here, that will allow us to SSH. Vim config. So 122 host name 192.168.253.55, and what this will allow us to do is just say SSH Ubuntu 2 without saying DSU or and saying at that IP address. If I configured it correctly again, SSH. So I just say SSH Ubuntu 2. Okay, so one of the things worth noting on these files in this directory is these are only supposed to be readable by your user. So I'll just chmod 660, which is user group read write on config, and then I'll SSH again. Really? That's weird. I'll try 600, I guess. So just user writable, readable, writable. Ubuntu 2. So that allows us to have just little aliases. So we can see instead of doing clear again here, SSH. What? I'm on Ubuntu 2. SSH. Instead of saying this, that's kind of a lot in my mind to remember. You could just say this. So this is SSH Ubuntu 2. Which is something that you might like to do is, again, as a system administrator, you don't want to necessarily remember all of these things. You might remember the host name for this box, but you don't necessarily remember what port you're running it on, what IP you're running it on, things like that. And it also allows you to keep track of different things. So let's say we had changed our port or something. We could say port 2222, and that would automatically connect with 2222. And it's just kind of a good way to remember all of that information. So I think that's about all I had for SSH today. There were a couple of things that I did kind of go over quickly, especially like the keys and things like that. Ideally, what I'd like to do is some sort of kind of man-in-the-middle demonstration eventually to show what that would actually look like. There's a number of tools, off-the-shelf tools that we could download and use to man-in-the-middle SSH connections, and it's just kind of generally fun. So that's all I have for you today. If you have any questions about Lab 2, definitely stick around. I'll probably be posting Lab 3, something to do with SSH, kind of the same things we've been doing in class today, relatively soon, and it should be on the same time frame as Lab 1 and Lab 2. So have a good day, everyone.